Hello Ravencoin lovers, Raven Rebels here with a developer update or a developer video. Let's spend 5 or 10 minutes to build something rather nifty on Ravencoin. And what are we going to build? Well, we are going to figure out what is the latest unique asset created on Ravencoin. And to do that we will use there's a Medium article by Tron Black, and he talks about the burn addresses for Ravencoin. Because when you issue a unique asset, in that transaction, a fee is sent to a burn address. And we can see it here. It's issue unique asset. So this burn address, that tells us that, okay, so for a unique asset to be created, some RVN has to be sent to this address. So let's make a script that will check this address for transactions and find the latest transaction and verify that it's actually a new asset being created. So let's do this. So we go over to Visual Studio Code or whatever code editor you are using. I have here a empty directory. So the first thing I do is type npm init y. So I initialize an empty directory, empty package. Nice. I have a Node.js project doing nothing. Step number 2, let's install the package Raven Rebels Ravencoin Reader. It's a very simple little tool that enables you to read data from Ravencoin network in just a few lines of code. So we do npm install at Raven Rebels Ravencoin Reader. And while that one is working, we create a new file and we call it index.mjs. MJS stands for modular JavaScript. So if you want to have the new module format in Node.js, you can create a file called MJS. So the installation of the package is done. So we start by saying import reader from Ravencoin Reader. Burn, and we define a variable burn address. So we have to go back to this article and find the burn address for unique assets. There we go. Good. And what can we do now? Well, there is something called deltas, and delta is like stuff go in and out to a transaction, and that creates deltas. So you can say reader get address deltas, and we send in the burn address. We found. So let's just run this code, see what happens, and see if it console logs. Oh, we found undefined. Why is that? Well, we have to await. Sorry, it's a asynchronous call, so we have to await it. We can't just expect it to be super quick. Okay, so we see that 47,402 deltas. So it's probably like 47,400 unique assets being created. But of course, since this is just an address, anyone can send anything to this address. So this might contain stuff that is actually not unique assets being created. So let's take the first, let's inspect the first delta. Let's print it out. Okay, so we see that asset name is Raven, height, so the height is the block number. Nice. And this is the amount of satoshis being sent to this address. Interesting. So first off, I think we have to sort the deltas. Wait a minute, we just print out all the data. This will go on forever, but we will cancel it. So to see that, okay, this is height number 682, 680, 679. I'm not sure if the deltas are always sorted. I'm not sure that it's always sorted. But let's assume that it looks like it's always sorted. So let's assume it is always sorted. So then we can just say, okay, post length equals deltas.length. And then we say deltas. If we print out the last one, we take the length minus 1 to get the last index in the array. No, this can't be the last one. It's such a low block number. So to be on the sure side, we want to sort the deltas. So we do a function sort, takes A and B, two objects, and it returns a.height minus b.height. So we say sorted deltas equals. So we create a new one, a new sorted deltas where we have sorted the deltas. And let's see what the first one gives us. We got a very, very low block number, so let's change this one. So we say, now when we sort them, we sort we reverse the sorting. So we say that sort by, oh, did I say that this is a low? This is a very high number. Good, it's a very high block number. We are reaching 3 million, so this is the one we think. Nice. So let's find the transaction for this one to see if it was actually a unique asset being created. Let result equals 0. So we created a result object and we will fill that with whatever information we need. And then we say that let's start working the let delta of sorted deltas. Let's just have a for loop going through the deltas one by one until we find what we are looking for. If result break, maybe this would do the trick. If we have the result, then we will stop looping. And then we say, so we say we know that we get a transaction ID. So we want to find the transaction. So we say await reader.get transaction. And what transaction is it? Well, it is a delta.tx transaction ID. And yeah, we just print it out to see whatever we have. So we will do some fancy panciness such as result equals a new object where we also add the transaction. Now this for loop will break immediately because we take the first one we have, right? So we can console log the result object and see what we get. We did get a transaction. Nicely, nicely. Object, object, object. So what we want to do is convert this to JSON, so we can result null 4. If you send in null 4, it will be indented. It looks better, more readable. So we do it again, and this time we get pure JSON, and we can see looky, lots of fancy stuff. We have a transaction that has a V, I guess it's a V out, the output of the transaction that contains, one of the outputs contains a type of new asset, and here we have the asset, so we assume that it's Nifty Moon that has the last asset. That's very nice. So let's do this. So okay, we get a transaction. We should then start looping the V. Let's make a for loop because it's more readable. I I try to avoid mapping and reducing and stuff because it's more readable this way. Okay, so now we have the vout object, and the vout object, what does it look like? Has a script pub key, and that has a property called type, and that type should be new asset. If vout script pub key and vout script pub key dot type, if it has that, then we check if vout script pub key dot type equals new asset, then we know that we are done. Then we have found the stuff we want. So let's and we know that we have this little result object, right? That if we assign the result anything, then our super for loop will break. So we say result equals, it should, and we want to have like the asset, and that will then be vout.script pub key dot asset. And we can also send in the transaction. So now we have both the transaction and we have the asset in our little result object. Nice. Let's print it out again. Let's run it. And let's only take the asset part so we don't get so much. Looky, looks good. So now we have the asset, and we hope that the transaction has a time. Let's go back again. Spent ID. The transaction has lock time, then there's via in, via out. Doesn't have like a time, only time. You know, if we want to be fancy, we can do this. Import fs file system from file system, and we can say that we take the first transaction, just JSONify it, and we say file system write file sync, write to file transaction, and we will, when we run this now we will have a transaction.json file, so it's easier to inspect it if we have a real looky, this is what we want. So we have all that fancy stuff, and I want to see, doesn't it has a time, here we go. The transaction has a time. We want to have that. We want to see time or block time, because we want to know in our little result, the transaction is so bloated. So we say time equals new date, and it is transaction.time times 1000. We have to add 1000. And block height equals, we set the block height as well, because we see here that it's height, transaction height is the block height. Nice. So now we have a result object containing information about the asset, the time when this block was mined, and also the block number. That's all. We don't need the transaction itself, right? It's boring. So let's run this again, and we can remove this file system stuff. We don't need it anymore. And we don't need that length. And we run it again. And here you go. Here we have a script that outputs the unique asset, the time, human readable, and this is and also the block height. And also, of course, since it's JavaScript, you can play around and say to locale string, for example, if you want to have the date formatted some other way, more readable for you with your time zone and stuff. Goodly. It works. So the cool thing is that we use Rebel's Ravencoin reader. That's a simple wrapper around the Rebel's Ravencoin RPC library that we have, and behind that we have Ravencoin as a service. We have publicly available nodes that you send your RPC commands to. It enables you to kickstart your development. You don't need to set up the infrastructure yourself. You can just take your computer, create an empty project, install Ravencoin reader, and if you want to know more about the stuff that me and my friends are doing, you go to ravenrebels.com, and here you see that here you can look at the Ravencoin as a service stuff. You can go to mainnet and do that, and you can install. You can also take all the tools you have here. So I hope you liked this video. If you did, leave a comment, drop a comment, like, whatever, share it. So hey, have fun coding. If you have any questions, just give me a question. Goodbye.